X-ray properties. X-rays are produced by acceleration of high-energy electrons or electronic transitions of electrons in the inner orbitals of atoms. It is invisible and high-penetrating electromagnetic radiation of much shorter wavelength than visible light. X-ray are partially absorbed by matter. There are two processes contribute to absorption. The true absorption, which the electronic transition within atoms of the material, and the X-ray scattering, which causes a loss of intensity in transmitted beam. X-rays are attenuated as they pass through matter. When X-ray pass through the sample, the X-ray photons are absorbed by the electrons of the atom of the material. This will decrease the propagating X-ray intensity and its wavefront. The decrease in intensity of the X-ray beam depends upon two factors, which is the depth of penetration or thickness and the attenuation or absorption cross-section. The intensity of an X-ray beam decreases as it penetrates through matter. It gives the information about absorbing material like the concentration of the sample. Factors that affect absorption are the thickness of the material, density, the chemical composition, and finally, the wavelength of the energy radiation. What is filter? Filters are materials that are put in X-ray beam to absorb radiation. It will absorb the lower energy X-ray photons emitted by the tube before they reach the target. A clearer image will be generated by absorbing the lower energy X-ray photons that tend to scatter more. Filters are also used in X-ray crystallography to determine crystalline lattice spacings using Bragg diffraction. In XRD, X-ray diffraction require monochromatic radiation to carry out the experiment. Undesirable intensity can be suppressed by passing the beam through a filter which absorption edge of K lies just between K-alpha and K-beta wavelength. Filters will preferentially reduce the intensity of the K-beta line compared to K-alpha. Filter materials are used in the form of thin foils or oxide of the metal if a given metal is not possible to obtain in the form of stable foil. The choice of filter material depends upon the choice of anode material in the X-ray tube as shown in the following table. The ideal choice of material for an X-ray filter is a metal whose atomic number, Z, is 1 less than that of the target metal for first-row transition metals. The effective angle on intensity is. The shape of the incident beam depends on the focal projection of the filament onto and from the anode material. X-ray beams that parallel with wide projection have a focal shape of a line. However, when the X-ray beams that parallel with the narrow projection have an approximate focal shape of a square, which is usually labeled as a spot. From this situation, as the angle from the anode surface is increased, the intensity of the beam increases, but the spot also becomes less focused. The effect of filtration on intensity is. Partial spectra of the unfiltered and filtered beams form a copper target as shown superimposed on a plot of the mass absorption coefficient of the nickel filter. Therefore, the thicker the filter, the lower the ratio of intensity of K-beta to K-alpha in the transmitted beam, but not the maximum energy of the X-ray beam spectrum. In addition, the change in the shape of the beam spectrum with filtration is referred to as beam hardening, due to the loss of lower energy photons. So, the average X-ray energy increased and becomes more penetrating.